Hello guys, welcome back to another video for an average programmer. Today we're gonna solve the problem 200 of Leetcode, which is number of islands. This is categorized as a graph problem because we will need to be treating each cell as a node of a graph. So yeah, I'm going to read the problem and then I'm going to show you the board because I think I explained this better with the board. Okay, so yeah, well, we will be given an m times n binary grid. These m and n are not specified as our input values for our function, so we can create those variables or not. And then we're going to see what to do, and we will be receiving ones and zeros. Okay, and these ones and zeros are going to be strings. Okay, and that is also evident in here because we are receiving a bidimensional array of strings. Okay, so we can expect to receive only one and zeros. Okay, and an island is surrounded by water and is formed by connecting adjacent lengths in both axes, x and y. Okay, so and we can also assume that the four edges of our grid are going to be surrounded by water. Okay, so that's really important. And let's see our first problem, but in the board. Yeah. So since this is a bidimensional array, we will have two indexes to check the different cells in our matrix. We will have I and j. Okay, and so this is an example of how the matrix is looking. And so let's zoom at the first cell. We have that in our first cell we have len, and in our adjacent cells we only have two because we are at the corner of our matrix. We only have two adjacent cells, and these are our length. Okay, so this is really important. And one thing to notice is that this whole island is considered as one island, and so we should be only increasing the counter of islands when we find one cell that is length. Why this? Because we will be expanding or checking the adjacent cells, but we don't need to increase the counter of the number of islands, because then we will have that the number of islands is the same number as the length cells. Okay, but let's just remember that we will be increasing the counter of islands when we find one cell of length. Okay, so let's go and try to create an algorithm. So we will be using recursivity because we will be scanning, or we will be calling the same recursive function in each cell. Okay, so this is basically a depth first search algorithm. So what do we need to do is to first scan the whole matrix with I and j. So we will be checking our cells, and there are two states for our cell. We can have water or we can have land. Okay, so what do we need to do in both states? That's really important. Let's also remember all the different states, because that is going to be avoiding some bugs in our code. Okay, so we have, what happens if we have water? If we have water, we can skip the analysis of that cell because we don't care about the water cells. We only need to count the number of islands. So it's not important to see what's in the water. Okay, but what happens if we have land? As I mentioned, we will need to be increasing the counter of number of islands, and we need to transform land into water, and we also need to check the adjacent cells. Why do we need to transform land into water? Because we can avoid the double checks, because we know that if we find water, we are not going to be doing anything. Okay, so if we could transform this cell into water, we already increase our counter. So that's the important variable that we need to return, the number of islands. We can just forget about that cell anymore. Okay, so that's really important, because if we keep this as a land cell, if by any reason we get to check that cell again, we will be repeating the recursive function with its adjacent cells, and that is going to be costing a lot of time complexity. Okay, so that's really important to take that in consideration. And we will need to transform each cell as water, and we need to check the adjacent cells. Why this? Because we will be also transforming the adjacent cells into water. Okay, so that's the algorithm. So let's code this. As I mentioned, you can create the variables of m and n, but those values are obtained from the length of our grid. So yeah, let me first create a mutable variable for our islands. Why a mutable variable? Because we will be increasing the number of islands every time that we find an island, and we will be returning that variable. So here's the return for that, because I sometimes forget to return the variable. And we will have a nested loop because we will be iterating over the bidimensional matrix. Okay, so let me do this. This is a traditional loop, so I'm going to do the same for j. And I'm going to be iterating while j is less than grid in the position of I length. Okay, and we will be increasing j in each iteration. And we only need to care about the land cells. So if grid in the position of I comma j is equals to len, which is equals to 1, we can increase our counter, and we will need to be calling our recursive function. So there are two ways of creating our functions. We can create a sub function of number of islands, and we can avoid to pass the grid because that variable is obtained from the same function. Or we can create another function in which we pass the grid and the indexes I and j. And that is also really important. You will need to ask to your interviewer, should I reuse this function for another problems? If he or she tells you that yes, then you can create another function for that. But in this case, I'm just going to create a sub function of number of islands. Okay, so that is going to be called as transform land into water, and I'm going to receive only I and j because and I don't need to return anything, so I will return void. Why passing I and j? Because we need to check the adjacent cells of each cell, and a good way to have the register of that is with the indexes with I and j. You're gonna see. Okay, so we need to find our base case, because if we do not find our base case, then this is going to be doing a lot of operations. So there are two base cases. Okay, the first one is the cells that are outside of our grid, because we will be checking at the right, left, up, and down. Okay, so we need to check also the cells that are not existent. So what happens if we do not have those cells? Then we can stop our algorithm. Okay, so that is for x, and then I'm going to be doing for y. Okay, so if I don't have any cell in those coordinates, then I'm going to stop my algorithm. And also, if my cell is water, then I can stop my algorithm, as we saw in our board. And we're going to transform the land into water. So that is done with this line of code, okay? Because we don't want to double check that cell again, and we just need to call our recursive function to our adjacent cells. Okay? Oh, sorry, I ran the code, but It was with a command, sorry. And a way to check the adjacent cells is with just increasing and decreasing the counter of I and J. So we're gonna do that. We're going to have, okay, so in this case I'm just going to decrease 1. I'm going to have the same for J. Okay, so this is basically checking the adjacent cells, and we need to call this recursive function when we find length, and we need to pass I and J. Okay, so this should be good. Let me run the code. Okay, so I have, oh, sorry, I misspelled length. This should be good now. Oh, so this is accepted in the 2 test cases. Let's submit our solution. Okay, so this passed, and the time complexity of this is the size of the grid, m times n. Okay, so I hope this was useful for you. If you like this video and if you found it interesting, don't forget to leave your like and subscribe to my channel. Okay, so see you in another video. Bye.